In this video, we are going to talk about the diffusion process. Diffusion. Here, we know that it is the concentrated related process. Concentration of the solute into the solvent. Here, suppose we have a beaker and it is filled with water. That is, the beaker is filled with water molecule. That is the H2O molecules. H2O molecules are present into the beaker. In the first case, we add some sodium chloride into the water. Then what happens here? We know that water acts as a polar solvent. Water acts as a polar solvent. That is, it is considered as a polar solvent. Water considered as a polar solvent. Then here we know that sodium chloride is the ionic compound. Sodium chloride is the ionic compound which is formed by loss or gain of electron. That is, the one electron is lost by the sodium atom and it carries positive charge, and one electron is gained by the chlorine atom, so that chlorine gain negative charge. Just like here, we know the atomic number of sodium is 11 and chlorine atomic number is 17. 2, 8, 1 and here 2, 8, 7. Here the one electron is lost by the sodium atom or the completion of octet, so that the electronic configuration of sodium becomes 2, 8, and due to loss of one electron, here due to loss of one electron, it carries sodium positive charge. Sodium positive charge, and by gain of one electron, the chlorine attains electronic configuration 288. Here the gain of electron is takes place. Gain of one electron is takes place. Addition of electron is takes place. And due to gain of one electron, that is mean we know that electron carries negative charge. Electron carries negative charge means gain of one electron is what? Gain of one negative charge here. And due to gain of one negative charge, chlorine carries negative. Here the oppositely charged, one atom lost electron and one atom gain electron, and this loss or due to gain of electron, the ionic bond is formed. Ionic bond is formed between the oppositely charged ion, between the oppositely charged ion, called as ionic bond, and the compound is called as ionic compounds. And ionic compounds are made up of oppositely charged ions, so that it is also considered as a polar substance. And here we talk about the polarity of the water molecules. Here we know that water is also polar, which is made up of two hydrogen atoms, and oxygen carries negative charge, delta negative charge, and water carries delta positive charge due to electronegativity difference. Oxygen is more electronegative, and hydrogen is less electronegative, so that hydrogen carries delta positive charge and oxygen carries delta negative charge, so that water is polar solvent. Water is polar solvent. And we know that when sodium chloride is added into the water, what happens? The sodium chloride is dissolved. It dissolves by formation of ions. By formation of ions, that is chloride ions and sodium ions. Sodium ions are surrounded by this positively charged hydrogen, and chloride ions are surrounded. Sodium ion is surrounded by oxygen atom, and chlorine atoms are surrounded by hydrogen atom. That means the sodium chloride is dissolved in water. Depending upon the concentration of sodium chloride, here the solution is classified into three types: saturated, unsaturated and supersaturated. We know that there is a less concentration of the solute present into the solution. When the less concentration of solute is present into the water, it is considered as an unsaturated solution. That is unsaturated solution. When less amount of solute is present, solute is dissolved. When the solute dissolve in solvent, solute dissolve in water at its equilibrium point, that is the proportion of solute into the solvent at its equilibrium constant is considered as a saturated solution. That is the equilibrium position, equilibrium constant. That is the no more solute dissolve into the water. No more solute dissolve into the solvent is considered as a saturated solution. And number third is the supersaturated solution. Supersaturated solution. Here, by increasing the temperature, some proportion of solute further dissolve into the beyond the capacity of saturated solution. That means by increasing the temperature, some amount of solute dissolve than its equilibrium constant. Then saturated solution is called as supersaturated solution. And we know that this dissolution of sodium chloride into the water, the homogeneous solution is formed. This is the general concentration of the solute into the solvent. For the understanding of diffusion process here, let us understand the different concentration of colored compounds. Different concentration of colored compound into the solvent. Suppose we have different types of compound like potassium chromate, like potassium permanganate, KMNO4. Here, let us have some amount of water present into the beaker. Suppose 100 ml water is present into the beaker here. If we add potassium permanganate into the water at the one corner of the water, here the potassium permanganate added into the water at this position. Okay, then what happens here? The concentration of potassium permanganate is increases at this point, at this area. That is the concentration of potassium permanganate is increases, and which is, we know that which is pink in color. That is pink color solution is formed at this area. That means the concentration of potassium permanganate increases at this point. After some time, the whole solution becomes pink in color. That means what happened here? We know that potassium permanganate pink in color. Here the transfer of solute particle from higher region to lower region is takes place. That is the transfer of particles. Solid particles here, transfer from higher concentration to the region of lower concentration, and this transfer of solute particles from the region of higher concentration to the region of lower concentration is called as diffusion process. Here the solute particles, that is the solid particles, are diffused from higher concentration to the lower concentration. Suppose second example here, we have a spray, a type of perfume, that is the gases. Here the gases is sprayed at this region, Then after some time it is found that the second region, the region which is present far apart from the region where the concentration is very high, is moved from higher concentration to the region of lower concentration. That is, the gaseous particles is also transferred from region of higher concentration to the region of lower concentration, and this is called as the diffusion process. This one is called as the diffusion process. What is my diffusion process? The transfer of particles from region of higher concentration to the region of lower concentration is considered as a diffusion process. Let us understand the second process is the osmosis here. Second process is the osmosis. That is the osmosis process. Let us have some beaker here that containing water. Here the water concentration is present. Then we place a semi-permeable membrane in between the two compartments. That is, the water beaker is divided into two compartments. This water is converted to two compartments by using a semi-permeable membrane. Then what happens? If we put some salt into the one compartment, suppose this compartment is classified into A or B type. That is, here the water concentration or water level at the both end is same. That is, the water concentration at this area and at this area is same. Then by adding some salt into the one compartment, into the A compartment, that is the A plus salt here. Then what happens? The salt dissolve into the water. And then what happens here? We know that here the salt plus water is present. Here salt, that means here A compartment, salt plus water is present, and second compartment, this is for the A side. And then for B side is water plus water concentration is present. Only water concentration is present. Here. Then what happened? We know that here the only water plus salt concentration is present. Here only water concentration is present here. So that we know that here the water concentration is more. Here the water concentration is more. There is no movement of salt takes place. In osmosis process. Then the water is start to move. Then what happens here? We know that the concentration at the B compartment is more as compared to the A compartment. So that the water is start to move from region of higher concentration of water to the region of lower concentration of water. In osmosis process, what happens? The water is moved from a region of higher concentration to the region of lower concentration. And we know that in B compartment the concentration of water is more as compared to the A compartment, so that water is able to move from semi-permeable membrane, but not salt. Salt does not move from the semi-permeable membrane. That is, the water is start to move from this compartment to this compartment, and after some time the level of this A compartment is increases. As compared to the B compartment, and the concentration of B compartment is reduced. That is, the amount of water present in the B compartment is reduces. Due to flow, due to movement of water from region of higher concentration of water to the region of lower concentration of water. Let us understand this concept with an example. Let us have, we have some cells. We have some types of cell. We know that in diffusion process, what happens? In diffusion process, the gaseous particle move into the cell and out of the cell depending upon the concentration of gases. We know that oxygen is taken from the air and which is transferred toward the cell into the mitochondria where the energy generation is takes place, where the ATP molecule is generated. So that we know that by diffusion process, we know that the at oxygen level is increases out of the cell. Oxygen level is increases out of the cell as compared to inside the cell. So that oxygen is transferred into the cell due to higher concentration of oxygen outside, and due to transfer of oxygen inside the cell, the carbon dioxide is suppose we have a cell here. Here the oxygen molecule is more. Oxygen molecule is more as compared to the concentration of oxygen inside the cell. Here the concentration of carbon dioxide is more. Carbon dioxide is more here. So that oxygen is able to transfer into the cell, and carbon, here the concentration of carbon dioxide is less. Lower concentration of carbon dioxide here. Here lower concentration of oxygen. Lower concentration of oxygen. Hence the oxygen is transferred or moved or enter into the cell, and this carbon dioxide is thrown outside of the cell. This is the called as the diffusion process. Let us understand the osmosis process. Further, by taking same example here, we have water into the beaker. Then we have water into the beaker, that containing salt solution. That containing salt solution. This is the salt particles here. These are the salt particles are present into the water. Then put some cells. Put cells into the water. Suppose in the first case there is no presence of, only water is present inside the beaker. That means the concentration level is same here. That is the concentration of water into the cell, and out of the cell is same. Here the water concentration into the cell and outside of the cell is same, so that there is no movement of water is takes place. That means here the first point is the concentration of water at both region is same, so that there is no movement of water. There is no movement of water is takes place. This solution is called as isotonic solution due to lack of movement of water, because the concentration of water at both regions is same, into the cell and out of the cell. Then put some salt solution. Put some salt into the water. Here the salt is added into the water. Then what happens here? Due to addition of salt, the concentration of water into the cell is higher. Here the concentration of water is higher into the cell, and the concentration of water outside of the cell is lower. Here H2O concentration is higher. Here the H2O concentration is less. That is H2O concentration is lower out of the cell. Then we know that here the water concentration is more, so that water is able to move from region of higher concentration to the region of lower concentration, and due to this what happens? The cell becomes shrink. Due to movement of water from region of higher concentration. We know that inside the cell the water concentration is more as compared to the concentration of water outside of the cell. Then due to this movement, what happens? The cell becomes shrink. The size of the cell becomes less, lower as in the previous case, as compared to the previous case, due to movement of water. Then this such a type of solution is, that means this is the second case here. This one is the second case. We know that the concentration of water into the cell is more, so that water is moved from cell to the outside of the cell, and this such a type of process is called as hypertonic solution. It is called as the hypertonic solution. Number third case here. Here, suppose the concentration of water is higher outside the cell. Here the concentration of water is higher. In the third case, what happened? The concentration of water is higher. Here the concentration is higher as compared to the previous case. Here the inside the cell, the water concentration is lower, and we know that cell is made up of a semi-permeable membrane called as plasma membrane. Plasma membrane is also called as the semi-permeable membrane, where the water is transferred. Here the water is moved. We know that outside the cell the water concentration is higher, and inside the cell water concentration is low, so that the water is flow from outside of the cell to the inside the cell. That is, entry of water is taken. That is, water is enter into the cell. So that the cell becomes bulges out. That means the third case here. The concentration of water outside the cell is more than inside the cell, so that water is moved, water is flow, or water is enter from outside of the cell to into the cell, and this such a type of process is called as hypertonic solution. It is also called as the exoosmosis, where the water is flow from inside to the outside of the cell, from higher concentration to the lower concentration, from cell to the outside of the cell, where the cell becomes shrink. It is called as exoosmosis. And in the second case, what happens? The water is flow from outside of the cell to the inside the cell by using semi-permeable membrane called as the hypotonic solution, and this osmosis is called as endoosmosis. This is all about the diffusion and osmosis process. Number third is the liquefaction process. That is the liquefaction. Our next topic is the liquefaction process. Liquefaction process. Then what is meant by liquefaction? The process in which here the liquid by applying pressure. The process in which the gas converted into the gas converted into liquid, gas converted into liquid by applying pressure, by increasing pressure and decreasing temperature, and decreasing temperature is called as liquefaction process, is called as liquefaction process, where the process in which the gas converted into liquid by increasing pressure. Here the pressure is increased and temperature is decreases here. For example, we have such a type of gas which is present into the container. Here the gas is present into this container, and we apply a piston. Here the piston are used to apply the pressure. Piston are used to apply the pressure, and from outside we place some ice cubes here. We place some ice cubes to reduce the temperature inside the container, to decrease the temperature inside the container. And due to decreasing the temperature and by applying a pressure with the help of piston, then what happens? We know that the gap which is present, the space present between the particles of matter is decreases. We know that in gaseous state the particles, that is the distance between the particles are more, and due to distance is more, there is an intermolecular force of attraction is less. We know that in solid state what happens? The particles of matter are present very close to each other, because and due to this the density is increases. Due to this density increases, and due to presence of particle very close to each other, what happens? The distance is decreases. Distance is decreases, and due to decrease in the distance, the intermolecular force of attraction is increases. Intermolecular force is increases by decreasing the distance between the particles. And in gaseous state we know that the distance between the particle is more. They are present far apart from each other, so that there is a less amount of intermolecular force of attraction present between the particles of gases. In the gaseous particles, we know that suppose this one of the container, the particles of matters of the gases are present are apart from each other, and so that the distance is more here. The distance is more in a gaseous particle, and so that the intermolecular force is less. Intermolecular force of attraction between the particles is less. As here we know that the effect of pressure and effect of temperature over the state of matter. Here, if we apply the pressure on the gases, we know that volume is decreases. We know that volume is measured in centimeter cube, and mass is measured in, we know that density is equal to what? Density is equal to mass upon volume, and which is equals to what? That is the mass is measured in gram upon centimeter cube. Also it is measured in kilogram upon meter cube. There are two different. One is for the SI and one for the CGS. And here, by decreasing the temperature, the volume of the gases become decreases, and their second effect is the temperature. And due to also we know that the thermal energy increases the kinetic energy of molecule. Thermal energy increases the kinetic energy molecule, so that here we decreases the temperature, so that thermal energy of the molecule is decreases. So that the thermal energy of the molecule is decreases, and so that by pressurizing the piston into the gases, what happens here? The particles of matter is becomes liquefied. That is the conversion of gas particle into liquid particle is takes place. Conversion of gas particle into liquid particles are take place. Then here the last concept of this topic is the conversion method of Celsius to Kelvin. Celsius to Kelvin. We know that here 273.15 Kelvin is equals to 0 degrees Celsius. Is equals to how many degrees Celsius? 273.15 Kelvin is 0 degrees Celsius. That means if we have a 5 degrees Celsius temperature, then we have to add 273.15 plus 5 degrees Celsius, which is equal to 278.50 degrees Celsius. This is the answer for this question. Suppose we have water, and we know that the boiling point of water is 100 degrees Celsius. We know that this is the common thing. 100 degrees Celsius. That is the liquid is get converted into gases. Liquid water is converted into vapor at this temperature. Then we have to convert this degree Celsius into the Kelvin. Then we have to add 273.15 plus 100 degrees Celsius. Plus 100 degrees Celsius, then which is equals to what? Here 373.15 Kelvin. It is converted into Kelvin. Here the degree Celsius. This is one is Kelvin. 0 degrees Celsius means what? 273.15 Kelvin. This is the conversion method. This one is the, suppose we have a 266 Kelvin temperature into the Kelvin form. Then we have to convert this into the degree Celsius. Then we have to minus this into 273.15, which is equals to what? 4 and 17. Then that one is the minus here. You have to put a minus sign. We have to put minus sign into this conversion method. 266 minus 273.15, which is equal to 70.50. Here the degree Celsius minus 70.15 degrees Celsius is converted here. This is the general conversion method of degree Celsius into Kelvin and Kelvin into degree Celsius. In the first case, what happened? We have to convert degree Celsius into the Kelvin. Then we have to here add degree Celsius into this value 273.15, and here we convert the Kelvin into the degree Celsius. At this point, what happened? Here the minus sign is used. 266 minus 273.15 is equals to 17.15 degrees Celsius. Then the last is the conversion of Fahrenheit into degree Celsius. We know that the conversion of Fahrenheit into degree Celsius is equal to, by using formula, degree Fahrenheit minus 32 into here 5 by 9 is equal to degree Celsius. It is converted into degree Celsius by using this formula. डायरेक्ट आप इसको इस तरह से भी यूज कर सकते हैं, दैट इज इंटू 0 पॉइंट विच इज इक्वल टू और इंटू 0.55 विच इज इक्वल टू, डायरेक्ट यहाँ पे मल्टीप्लीकेशन किया तो भी चलेगा. दैट इज द Fahrenheit. -32 into 0.55 directly converted into the degree Celsius here. Then conversion of degree Celsius into the Fahrenheit. Then conversion of degree Celsius into the Fahrenheit here. Then here degree Celsius plus 32 here plus 32 here, not 32 here, the degree Celsius into 9 by 5 and here plus 32 here plus 32. This is the conversion method. This one is the direct, this value is converted directly into the Fahrenheit. Here the value is directly degree Celsius. That is the degree Celsius. It is multiplied by 1.8 directly with this then it is at 32 and it is directly converted into the Fahrenheit unit. These are the different conversion method from Fahrenheit to degree Celsius and degree Celsius into the Fahrenheit. So this concept is over here. Then all topics, next topic we will see tomorrow. Thank you.